Okay, we have a new kind of problem here, and that is that we're given the value of one of the trig functions. In this case, the tangent is 3/5, and we're also told the quadrant is quadrant 3. Now, understand we need to have this information because the tangent of positive 3/5 could be achieved in either the first quadrant or in the third, so we're told that it's in the third quadrant. All right, since we're in the third quadrant, that means that both the x and the y coordinates are going to be negative. Since the x and y coordinates are both going to be negative, that means we have opposite over adjacent here. This is x, this is y for our reference angle. So 3/5 is the value of our tangent here. That y coordinate is -3. And the x-coordinate is -5. If we're just talking about the triangle, of course, you could say that this side of the triangle is 5 units long and this side of the triangle is 3 units long. If you worked with the positive versions, it would tell you the reference angle for theta here, but we're really interested in this total angle now. All right, so we have the opposite over the adjacent is -3 over -5. That's plus 3/5, which agrees with the specification we were given at the beginning. What about the sign? Well, the sign is the y coordinate, which is -3 divided by the radius. Well, the radius we get by taking the square root of the sums of the squares of the y and the x coordinates. So 3 squared plus 5 squared, 9 plus 25, 34 is the sum, root 34 is the radius, and therefore the sine y over the radius is 3 divided by root 34. The cosine, on the other hand, is the adjacent, -5 over root 34. The cotangent we can get is simply the reciprocal of the tangent. So instead of 3/5, we now have 5/3. Secant is the reciprocal of the cosine, minus root 34 over 5. And the cosecant is the reciprocal of the sine, which is minus root 34 over 3. So there are the values, the exact values of all the trig functions from the tangent and which quadrant we are in. Now, in principle, you can do this for any of the functions. So we'll do another one here in just a bit with the sine. This time we're going to do a problem that has a little bit of a different twist to it. The sine of theta is 1/2, and we're in quadrant 2. Now, remember, the sine is the y coordinate on the unit circle. So knowing that the sine is positive 1/2 tells us quadrant 1 or quadrant 2. This has simply narrowed it down to quadrant 2. The other thing we know is that the sine is 1/2. So if I were on the unit circle here, this would be 1/2, and on the unit circle this would be 1. Well, my goodness, is one of our special angles. This is a 30-degree angle in here, and this side is root 3 over 2. So every once in a while you're given a problem where it's a special angle, and then you can just draw the picture immediately. You know what's going on. So the cosine of theta. Now we want to express things in terms of x and y coordinates. So the x coordinate is minus root 3 over 2, and the y coordinate is plus 1/2. So we'll keep track of the plus or minusness of all of these ratios. The cosine is minus root 3 over 2. The tangent, that's going to be minus root 3. Sine over cosine, minus 1 over root 3. Or you could get it this way. It's the opposite over the adjacent, so you'd have 1 over root 3, and negative because the x is negative and the y is positive. The cotangent of theta is the reciprocal of this, minus root 3. The secant of theta is the reciprocal of the cosine, minus 2 over root 3. And that's secant. And the cosecant of theta is the reciprocal of the sine, that's positive 2. So there are the rest of the trig functions, each of which can be computed exactly.